Saxon Algebra 2, Lesson 10. Look, you guys, it's another one-topic lesson. It's Pythagorean Theorem. It's going to be short and sweet. I'm excited. Remember that we first learned about the Pythagorean Theorem. Look, I forgot the R. Last year, it was Lesson 97 in the Algebra 1 curriculum, and this is a great example of how John's genius works. He planted that lesson in your brains, in my brain too. 97 is getting toward the end. It was probably about March when we tackled that concept, and we had a chance to practice it, but it was pretty near the end of the year. So now what he's doing is he's bringing it back fairly close to the beginning of this year and giving you another look at it. And the idea is that our brains have had an opportunity to begin to build some memory around this. But if that was the first time you saw it, you probably don't have a really strong memory of it. It's probably a little hazy now that you look back, almost 6 months ago, and try to remember what the heck that was. But that's okay, because John's going to come back and he's going to reinforce it. And we're going to use it a lot more this year than we did last year. And then when you get to advanced mathematics next year, guess what? You're going to review it again and build upon that some more. So it's not a one and done kind of curriculum. It's a circling back, it's spiraling so that you build the strongest memories of how that works, of what you're learning. All right, Pythagorean Theorem was developed by this great guy who lived in an island off Greece, as I recall. And he was the fascinating hybrid of the day. They used to be philosophers and mathematicians. Those two things went together. In our world, they don't seem connected, right? Don't you sort of have the perception that people who study philosophy are kind of like head in their clouds, not very practical, you're never going to get a real job? But people who study mathematics, oh man, they're STEM folks, right? They can be engineers and computer scientists, and it seems very practical and down to earth and gritty. Well, that's our hang up, and that's not necessarily the way everyone has viewed those two subjects. So these guys fooled around with all kinds of interesting philosophical things and also studied math. They went together. Here's the thing about Pythagorean Theorem. It only works on right triangles. On right triangles, here's the corner where all the action is, right? There's the right angle. And then there are two sides that come straight out of that corner. These are called the legs. Whoops, I should have just said leg. And the standard is to call them A and B. It doesn't really matter which one's A and which one's B, as long as the legs are A and B. This side, the side that is opposite the right angle, is called the hypotenuse. And that's the side that is normally called C. That one has to be different than these two. The way that the Pythagorean theorem works is that if you take one leg and square it and add the other leg squared, you will get the square of the hypotenuse. It's very cool for finding the missing side of triangles, as we will see, and there will be other applications. Put this into your notes. Draw the picture to remind yourself it only works for right triangles, and that the A, B, and C sides have to correspond properly to the shape of the triangle. Okay, pause me if you need to. All right, you're back now. These pictures, I'm going to tell you this specifically. Don't worry about them. John's trying to give you a theoretical underpinning for why the Pythagorean theorem works. Most students look at that and go, what? So just don't hurt yourself. Trust me, it does. And if you ever want to talk to me about what those pictures mean, I would be happy to, but it's more of a nice to know than a need to know. Example 10.1. Use the Pythagorean theorem to find side A. And here comes a cute little triangle. And we see this. And I say yay. It's a right triangle, so Pythagorean will work. It's reversed to the way I drew the triangle up here, but that's okay. We can still see, oh, these are the legs. These are the straight sides that come out of the right angle marker, and this is the hypotenuse. It's opposite. So we're oriented. We've got some numbers here. There's a 7, and there's a 4, and there's an A. We're supposed to use the Pythagorean theorem to solve for A. Okay, well, this is one of the legs, so let's just let that be A, and we'll let that be B, and this one has to be C because it's the hypotenuse. So there's our Pythagorean theorem. So we're going to say A squared plus B squared is 4, so that squared at 16 equals C squared 749. Make sense? Hit it with an algebra stick. A squared equals 33. Here comes the fun part. We just take the square root, and we're going to say that A equals square root of 33. We do not need to take into account the negative square root. You know how when we take a square root, there's a positive and a negative? If you remember back to our old friend, the man-eating dragon, aka quadratic formula, we normally have to do a plus and minus, but geometry is all about shapes, and there's no way that this length could be negative square root of 33. So in geometry, we get to throw out a lot of negative roots, and that's kind of fun. This is the only answer you need. And we can double check to make sure this can't be simplified. 33, the prime factoring of that is 3 times 11, so there's no pigs to take out. So this is our final answer. Yay. And there's just one more problem, and I'm going to squeeze it here so that we can have said we put the whole lesson on one page. 10.2. Use the Pythagorean theorem to find the distance between the points 4, 2, and minus 3, 4. Okay, let's draw the picture before we panic over this. We have to graph these little doggies. I'm going to have to squish my numbers because I don't have a lot of space. 1, 2, 3, 4. Okay, I'm going to graph these 2 points. 4, 2. 1, 2, 3, 4, 1, 2. And minus 3, positive 4. Okay. We're supposed to find the distance between those 2 points, and we're supposed to use the Pythagorean theorem. What in the world? Okay, here's the trick. We're going to draw a triangle, a right triangle, to connect them. I'm going straight down until I get to the line where this is, and then I go straight across. Now I can connect that as the hypotenuse. That is reasonably straight. All right. Now, we're trying to find this. We can see that's the hypotenuse because there's the square that I made. So this is C. Now we need to know how long these 2 legs are. Well, guess what? We can figure it out because we graphed it neatly. This, right from this bottom line where this point is, up here, it's 2 units. And along here, it's 1, 2, 3, 1, 2, 3, 4. So this should be 7. Right? And we can check that by looking at this. The difference in the x's goes from 4 to minus 3, so that's 7. That's how we got that. And from 2 to 4, that's how we got that. That's just the 2. Okay? So by graphing the points, connecting the dots, and then making that the hypotenuse, we can set this all up for action. I remember learning this and thinking, but I don't understand why you don't draw the triangle this way. And guess what? You can. If that's the way your brain sees it, go right ahead, because you know what? This is still 2 units, and this is still 7 units. I'm writing on my old numbers, but you can see. It works out exactly the same. If your brain wants to see the triangle that way, go for it. It won't change the answer. Okay, so now these are our legs, right? So we'll let that one be A, we'll let that one be B. It doesn't matter as long as we're sure that C is the other one. So A squared plus B squared equals C squared. A squared is 4 plus 49 equals C squared. And 4 plus 49 is 53. I'm going to take the square root of both sides. Let me just write that there. So C equals square root of 53. 53 is prime. So we can't simplify that. That's our final answer. These aren't necessarily really satisfying answers, but because they're square roots, which are kind of weird. But we know that this one, let's see, 38, it's a little less than 6, right? Because if it was square root of 36, it would be 6. And this one's a little bit greater than 7 because the square root of 49 would be 7. So that gives us kind of a, oh, excuse me, I'm yawning, kind of an eyeball, kind of a rough test. And that makes sense. This one's a little greater than 7. And this side is 7. So we'd want that to be greater, but not, we don't want it to be 52. And this one we said is 6. Yeah, that makes sense. If this is about 6, and then that's 4 and 7. Right on. Okay, lesson 10. A round of applause for you. Good luck with your homework. I'll see you later. Goodbye.